All right, welcome class. Today we're going to start off with conversions. So conversions of volumes, lengths, and masses. Those are the main things we're going to be concerned about. Volumes, because in the nursing field, you're going to be administering volumes of solutions, drugs, things like that to people, right? Lengths, because you're going to be measuring the heights of people. And then the last thing, masses, you're actually going to be weighing out, let's say medications, or you might even be weighing out people. So we need to be able to convert from kilograms over to pounds, no problem. We might need to be able to convert from nanograms to milligrams to grams, no problem. So that's what we're going to be doing. And I'm trying to provide a little bit of context as to why we're going to be studying what we're studying. So with that, let me share my screen with you. This is posted on the Moodle page. Actually, I had a good question from Katie. Katie was wondering, oh, there's a couple of people still in the waiting room. Let me admit them into the class. There were a couple of people wondering whether or not we had a quiz today or any assessments today, and that's a negative. So I'll show you where you can find all of that information regarding where our assessments are and when our assessments are. So if you go to the My Cambrian and you start off on, my page might look a little bit different from yours, but this is the way my page looks. And if I click on a syllabus, the syllabus is this kind of a book icon. I can download the syllabus that I just created last week. So I can preview a modified syllabus. And so what will happen is I can actually view week by week what Miss Labine or Emily Labine is planning on covering with the class, right? So this is week 3, and today we're planning on covering measurement systems and conversion, dimensional analysis, metric system, and non-metric system. So the resources that you can use are chapter 3, page 99 to 124. And will there be any evaluations this week? That's a negative, right? So can you see what I'm sharing with you? I hope you can. I hope you're looking at the same document as I am. Okay, so next week, we do have an assignment that's due on Monday, right? February 1st. So I haven't yet released it. I'm still in the process of creating it. It'll be released sometime tomorrow. So you'll have about 6 days to complete it. And it's just going to be a summary of what we've learned so far. So it will basically be week 3, dimensional analysis and conversion of units. Week 2, where we looked at unit rates, word problems, converting fractions to decimals to percentages and vice versa, and where we looked at orders of operations and everything listed here. So that's what the assignment's going to cover. It's going to be covering a lot of information. Do you have an Excel sheet syllabus on Moodle that says we have a test today? So no, France, the document that overrides what I had on Moodle earlier, I've taken that document down. This is the document that now overrides what I had on Moodle earlier. So what I had on Moodle earlier was the plan about 3 weeks ago, but that plan's changed. So this plan is more up to date, okay? Okay, yeah. So this is the syllabus. If there's anything that changes, like this is a dynamic and fluid syllabus, it could change. I could be moving one thing to a different week. I could be moving algebra and I could be switching chapter 4, but I'll let you know ahead of time. And if you're wondering what kind of evaluations are coming up, this is where you should go and have a look. Okay, so there is an assignment number 1 worth 4%, and that's due next Monday. Okay, but I will release that on Moodle tomorrow sometime. So you'll have 6 days to complete that. All right. Now that covers that. Are there any questions about assessments or due dates? It's pretty much all summed up right there. Are there any questions about assessments or due dates? No? Okay. So let me share my screen. Where do we find the assignment? The assignment will be posted on Moodle, and I'll show you where it will be posted on Moodle. So if we go back to Moodle, and I go right here, it'll be posted under week number 3. Right under this one, there'll be one more activity, and it'll say assignment number 1, and then you'll be able to find it under week number 3. Okay. All right. Trying to keep up with the chat here. Yeah, okay. Great. And okay, so now we're going to cover chapter 3 of the textbook. And mostly what we're interested in is converting within the metric system. Because we're Canadian, we're going to be converting within the metric system. So we're going to be looking at gotta admit the latecomers to class. Okay, so we're going to be converting from milligrams to grams to kilograms, milliliters to liters, millimeters to centimeters to meters. Those are the main units we're going to be converting. So that's weights, volumes, and distances. Okay, and then since we are somewhat dependent on the United States for some of our products, we're going to have to convert from the imperial system to the metric system and vice versa. So that we'll have some practice on that as well. And then number 3, we're going to be able to convert from the metric system to the imperial system for weights and heights specifically. So let's say, for instance, you're a nurse someday and you're weighing somebody and you say, hey, Joe, you weigh 80 kilograms. And he says, oh, well, that's great, but I don't know what that actually means, because he's more used to pounds, right? So you're going to have to convert from kilograms over to pounds. And then same for height. If you measure somebody in centimeters and you say, okay, you weigh, or you're as tall as 190 centimeters. Well, a person's going to say that, well, that doesn't mean anything to me, because heights are usually measured in feet and inches, right? So I'm 5 feet 2 inches tall, right? Something like that. And then last but not least, we're going to look at temperature conversion. So from Fahrenheit to Celsius and from Celsius to Fahrenheit, vice versa. So it might sound like a lot, but once you know the trick, it's actually really straightforward and it's very easy. And I'll show you what that trick is today. It makes it easy to convert from anything once you know how to do dimensional analysis. Now, dimensional analysis might sound a little scary, but all that it is know your units and watch your units cancel, just like we've been doing in week number 2. We did that in week number 2, and I think we might have even done it in week number 1 as well. And once the units cancel, then you're able to convert from one unit to another unit. All right, so when we're converting within the metric system, we might be converting lengths. So millimeters are represented as a small m, lowercase m's. Everything's in lowercase for the metric system in terms of the symbols, right? The symbols for the units. If you want to spell the units out, you can spell them out the French way, where it's RE, or you can spell it out the English way, ER. Then for masses, here we have grams and kilograms. So that's just 1,000 grams is equal to 1 kilogram, right? So we're off by 3 orders of magnitude. That's what that means in terms of decimal place, essentially. That's what that means. So 1 centimeter is equal to 10 millimeters. You could also say there's 100 centimeters in a meter. So "100 centimeters equals 1 meter." Oh yeah, it says it right there. Whoops. Okay, never mind. I didn't have to write that. And then, so for a kilometer equals 1,000 meters. So once we have these factors, we can actually convert from one unit to the other unit. So if I say, please convert 300 meters to kilometers, all that we have to do is basically set up our conversion factor, which is 300 meters, and then we multiply by, well, we need to know how many meters are in a kilometer first. And we know that 1,000 meters equals 1 kilometer. And this is actually our conversion factor, what I've just started off. So we're going to put 1 kilometer as the numerator and 1,000 meters as the denominator, and watch them cancel, right? Watch the units cancel. Meters cancels with meters, and we're left with basically whatever 300 divided by 1,000 is equal to. So 300 divided by 1,000 is equal to 0.3 kilometers. So that's converting 300 meters to kilometers is 0.3 kilometers. So that's how we take all of these here are conversion factors. Once you see something is equal to something else, that right there is a conversion factor. So I can start these ones off too for mass as well. All right, so we can do the same for millimeters squared, although area is not as common in the healthcare field, so we won't really be focusing on that one as much. Volume, now that's used in the healthcare field, so we would be focusing on that one, where we have milliliters, liters, cubic centimeters. So one thing to note is 1 milliliter is equal to 1 cubic centimeter of water. So that's something to note in the healthcare field. All right, and then also of note here, units smaller than a meter have Latin prefixes, like deci means 1/10. So whenever you have a decimeter, so sorry, decimeter. Let's say if I was to write decimeter, so 1 meter, if I was to have 1 meter, a decimeter is 1/10 of a meter. So 1/10 of a meter is equal to 1 decimeter. So that's what the term deci comes from, is 1/10. Centa is the same. So 1/100th of a meter equals 1 centimeter. And then milli means a thousandth. So 1/1000th of a meter equals 1 millimeter. So that's where those prefixes come from. Any questions so far about conversion factors and the metric conversion chart? Are we doing fine so far? Or are you looking for practice? Is that what we are waiting for?
I understand it. That helps.
Okay. Okay, so let's get to some practice. How about that? I think that's where the rubber meets the road, and we actually get to figure out whether or not this is actually making any sense. Okay, let's try some practice. I'm just going to move this over. I mean, it would be a lot easier if I was in class and I could actually see what was going on, like whether there were glazed looks happening or whether there was actual like nodding, which would mean something is actually registering with you. But so I'll save this one for tomorrow. We'll talk about conversion within orders of magnitude tomorrow. I'm going to save that one for tomorrow. But how about converting from meters to centimeters? So if we know, well, this is a little fuzzy, but if I scroll out a little bit, it looks a little bit better actually. So here's a couple of practice rounds that we can do together. So number 1 says convert 31 meters into centimeters equals how many centimeters? So the way that we do this is we need to know how many meters there are how many centimeters there are in a meter. So there's 100 centimeters equals 1 meter. Or you could do this the other way around. There's 1/100th of a meter equals 1 centimeter. You could do it that way as well, and you get the same answer, but let's just stick to the first way for simplicity's sake. All right, so the way we set this up is 31 meters times, and then we have our conversion factor where centimeters goes on the top, meters goes on the bottom. We watch the units cancel, so meters cancels with meters, and we're left with basically 31 times 100, which is equal to 3,100 centimeters. So that's how to do conversions of meters over to centimeters. All right. And everybody put that into the chat. That's awesome. Thank you. All right. How about question number 2, converting from centimeters over to millimeters? So if we have 22 centimeters, this equals how many millimeters? So 22 centimeters, and then we're going to have to multiply that by a conversion factor. So first I need to figure out what my conversion factor is. So I know what my conversion factor is. It's going to be how many centimeters are there in a millimeter, or vice versa. So there's going to be 10 millimeters equals 1 centimeter. I know that intuitively, but I could also bring out a ruler stick and just count them and say, okay, so in 1 centimeter, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 millimeters. And then I can set it up like this. So 22 centimeters and then multiply by 10 millimeters over 1 centimeter. So people are saying 220, and that's correct, yes. So it's off by a factor of 10. Or sorry, you just have to multiply by 10 in order to convert from centimeters to millimeters. But I think it's important to know why we multiply by 10, and it's due to this conversion factor right here. All right. Now, could we convert from, the next step would be to go from something very small to something very large, like nanometers all the way up to like kilometers. But I might save that for tomorrow. Yeah, so let's try another one. Let's try, just going to do 3 examples of this before we move on to volume or the next topic. So let's try 1,000 millimeters equals how many centimeters? Oh, sorry, this is, yeah, millimeters. So I have to have 2 M's. Okay, so 1,000 millimeters equals how many centimeters? So the way that we do the conversion is 1,000 millimeters, and then we have to multiply it by however many centimeters there are in a millimeter. Oh yeah, this conversion again, right? There's 10 millimeters in 1 centimeter. So we're basically taking 1,000 and we're dividing it by 10, which means the decimal place moves over 1 to the left, like this. So did you get 100? Check the chat. A 2-step question. Yeah, we could try a 2-step question. All right, let's try several orders of magnitude. I'm going to complicate it a little bit. So let's have a look at this chart. We know that centi means 1/100th. We know milli means 1/1000th. Micro means 1/1,000,000th. Nano means 1/1,000,000,000th. Now we're starting to get more complicated, right? So this might be a multi-step conversion. So if I say, can you convert 1 microliter to a milliliter? This is something that you actually might see in the field as a nurse. So we know that 1 microliter, I'm just going to zoom in so you can actually see this a little bit better. That's not the way I wanted to zoom. There we go. There it is. Okay. So what we have here is 1 microliter, and micro means 1/1,000,000th. So if you count the number of zeros here, it's basically 1 divided by 1,000,000. So let me show you how to do this. 1 times 10 to the power of -6 liters equals 1 microliter, right? We could write it that way, or we could say 1 over 1,000,000 liters equals 1 microliter. So it depends on which way you'd like to write it. Do you like it written in scientific notation? Do you like it written as a fraction? How do you like it written? Because I don't want to confuse anybody if I write it in scientific notation or anything like that. Scientific notation? All right, so I'm getting votes for scientific notation, so let's do that. So micro means 1 times 10 to the power of -6. So I'm going to start writing it in scientific notation. That's why we taught that in the week number 1, is because we knew it would come in handy later on. Okay, so scientific notation, here we come. So in order to convert this from microliters to milliliters, we're going to say, okay, so 1 times 10 to the -6 liters equals 1 microliter. And 1 times 10 to the -3 liters equals a milliliter, 1 milliliter, okay? So let me just try to set this up here. So question number 1. So I used this conversion factor right here. And so what I did was I wrote microliters instead of using the symbol micro. So this is a micro symbol. That's what this means. You might also see this in medicine as MC, but this Greek term is M micro. It's actually mu. Okay. Anyways, so back to this. 1 and then times 10 to the -6. This entire thing right here represents micro. So this is 1 microliter times, and then this is the conversion factor that I'm going to be using right here. So I'll highlight that in yellow. All right, so here's my conversion factor, right? And then we're going to see how the units cancel. So watch how liters cancels with liters. And what I'm left with, so 1e -6 divided by 1e -3. So 1e -6 divided by 1e -3 equals how many milliliters? 1e -3 milliliters. Or this is equal to 1 over 1,000 milliliters. It's 1/1000th of a milliliter. Does that make sense? Should we do a couple more examples of that level of conversion, I think. Okay, so I'm trying to keep up with the chat, although it's really distracting, guys. I'm sorry, I can't keep up with the connection issues and things like this. So Katie, you don't understand. Can you pipe in which step you don't understand, please? You're usually pretty vocal. Now would be a good time to vocalize. Vocalize any issues. Can't we just use the metric conversion?
I think the 1e -3 kind of threw some people off.
Oh, okay. Yes. Okay, so I can write that differently. That's 1 times 10 to the power of -3, which is equal to 1 over 1,000. So 1 times 10 to the -3 equals 0.001, and that equals 1 over 1,000. So if you type 1 divided by 1,000 into your calculator, you'll get 1 divided by 1,000 equals 1e -3, or 1 times 10 to the -3.
Yeah, the E is just a way to say to the power of, like, right?
Yeah,
Some
exactly.
calculators show it that way, right? Okay.
Yeah, E means times 10 to the power of.
And like in my mind, I would have just moved the decimal places over 3, regardless of what the number was, because you're going from one metric. You're staying like it's a liter, so you're going from a liter to a liter. You're going microliter to milliliter. You just move the decimal over 3 places, and you get the same answer. All this math for nothing because it's a scale. So like,
Yeah,
kind of hard to mess up. I don't know.
exactly. So what Sandy and Adam both were saying is essentially 1 microliter. So if we're going basically from micro to milli, that's 3 jumps, and the decimal moves 1, 2, 3 spots to the left. So you're left with 0.001, and then this turns into milliliter. Because we're jumping from -6 to -3. So that means we're jumping 3, the decimal is going to be moving 3 spaces. So the decimal moves to the left 3 spaces because we're going from micro to milli, right? So that's what Sandy was saying. So that's like another way of doing it. It's much simpler than, yeah, it's much simpler like that. So the conversions in physics and on the metric line. So I think that's where we are confusing on the formatting. Okay. Yeah.
Do you mind if I just I I appreciate you laying that out because it helps me to see the actual equation. But really, what you were doing is taking -6 and like it, just to help me understand, you're taking -6 and you're subtracting -3, right? So
Yeah.
you're
So
getting -3, which still moves the decimal 3 points to the left.
yeah. So think about it this way: -6 minus -3. So a negative, like 2 negatives beside each other equals a positive, right? So -6 minus -3 equals -6 plus 3. So -6 plus 3 equals -3. So the decimal's moving 3 spaces to the left because overall your net exponent is still -3. Yeah, because it's -6 minus -3. Yeah. Okay, so that's a bit more complicated, right? And there's 2 different ways of thinking about it. So one way is doing it mathematically like this, and just setting up the equivalencies, right? Or the other way is like Sandy and Adam's way, which is completely equivalent. Well, it's equal as well. We're going from micro to milli, which is 3 units or 3 decimal places. The decimal is going to move 3 places to the left, going from micro to milli. So let's try one more. How about nano to milligram? So nano's here and milligrams way up here. So that means we jump the decimal is going to move how many places to the left if it's going from nano all the way up to milli? Type that into the chat if you know the answer. So the decimal is going to move 6 places to the left. Exactly. That's right. So if I have 1 nanogram, how many milligrams do I have? So let's say the dosage for the patient is 1 nanogram. How many milligrams did I give my patient? So the decimal place has to go 1, 2, 3, 4, 5, 6 places over to the left. And what we're left with is 0.00000. So we have 1, 2, 3, 4, 5 zeros. So what we're left with is 0.000001 milligrams of substance. All right. Yeah, that's right. That's awesome, Adam. Yeah, -9 minus -3 overall is -6. That's how I see it in my mind. Yes, there you go. Do we have to write E? No, you don't have to write E. You can write times 10 to the power of if that's what makes it more simple or makes it more straightforward. All right, what about now? I'm going to create a bit more of a page break here because I think we're on a roll in doing some of these questions. So how about micrograms to nanograms? Now we're going from this box right here all the way down to nano. How many places do we have to move the decimal? Yeah, so Sandy's saying three spots to the right. That's correct. So if we're converting micro to nano, we're converting 300 micrograms to nanograms. And then this decimal place is going to be moved 3 spots to the right. How many nanograms are we administering to the patient? Right, so we're here at micrograms and we're jumping down to nano. Sandy says we're moving the decimal place 3 spots to the right. We have 300 micrograms and we're jumping down to nanograms. So Ryan is saying 300,000 nanograms. Awesome. Yeah. So don't forget your units of measure. So 300 micrograms to nanograms equals 300,000 nanograms. All right. That's great. Thank you, Adam. Thanks, Ryan. That's good. Ooh, now this one's a toughie. Okay, from micrometers to centimeters. So micros here, centi is up here, and micro is times 10 to the -6, where centi is times 10 to the -2. So how many places are we going to move our decimal from micro to centi? Is it 4? So yeah, micro, so times 10 to the -6 minus -2 equals -4. All right, so the decimal is going to be moved 4 places to the left. And we're going to convert 1 micrometer to 2 centimeters. There we go. All right, so we've moved the decimal 1, 2, 3, 4. Let me see again. 1, 2, 3, 4. Excellent. Thank you, Adam. Yeah. So that's the correct answer is 0.0001 centimeters. So James is asking, when formatting an answer for these questions, would you prefer in scientific notation or in the 300,000 nanograms? So I would prefer scientific notation, I think, although I will be specific when I ask a question in a quiz or in an assignment to, I'll say explicitly, please express your answer as a scientific notation or in scientific notation. Okay, thank you for the question, James. All right, and last but not least, we have one more. We're going to convert 1 centimeter to a nanometer. So we're going from times 10 to the negative 2 all the way to 10 to the negative 9. So how many places will we move our decimal? And Sandy and Ryan are saying 7, that's right. So the way that we got 7 was negative 9 minus negative 2 equals negative 7. And the decimal will be moving to the right 7 spaces. So that's 1 followed by 7 zeros. All right. Yeah. So how would we express this answer in scientific notation? Number 5. We're going to
Wouldn't
count.
you? Oh, sorry. I was going to say, wouldn't you just take the 7 that you originally used and then just put 1 times 10 to the power of negative 7? Or
Is it
sorry, not negative 7? No, positive 7. Sorry.
Yeah, 1 times 10 to the power of positive 7 nanometers. That's right. Yep. Awesome. Yeah, that's correct. All right. 1 times 10 to the power of E7, or forget that E, but yeah, 1E plus 7, or 1 times 10 to the power of 7. Yes. So that's correct. Yep.
Sorry, which one's right? That's what I'm just.
Oh,
Confused.
this one right here. 1 times 10 to the power of 7. You could also say 1E7 nanometers. Those are the same thing as well. Yeah, they're saying the same thing.
Thank you.
No problem. And in terms of what I'll be giving you on a test, I will be giving you the conversion factors. I could even give you this diagram if you like on a test. I don't know if you find this particularly helpful or not. Would you like it on a test? Like I could give you conversion factors and just say there's like 100 centimeters in a meter. So someone's saying yes. So, okay, so I can give you this particular SI unit conversion chart on a test if you like. That's not a problem.
I'm
Okay.
confused. Are you saying you're going to test us on it, or you're going to provide it for us to use?
I can provide it for you on the test.
Oh,
like
okay.
As in like for you to use on the test. Yeah, not
Sorry.
not to test you on how to use it. Well, I mean, the test, well, never mind. yeah, you know what I mean. Okay. All right. Yeah, so that covers I guess that covers more of like the more difficult things that I wanted to get covered. Yeah, I was going to cover that tomorrow, but anyways, we covered it today, so that's good. Let's see, what else could we cover today? All right, so if we know how to do that, then chances are we know how to do the rest of this. Let me just have a look at what else I have in store. Yeah, so we're going to be converting. This is all very basic, but I could actually change it up a little bit and say this is instead of saying this is 79 grams, what I would say is it's 79 micrograms. and then have like several orders of magnitude conversions, or we could just stick to what's there. So it's 79 grams. Let's see, what else do I have? I have milliliters to liters conversions. I have kilograms to grams conversions. I have milligrams to grams. So that's a fair assessment right there. Then we have, okay, this is getting a little bit more complicated. The metric to imperial system. All right. All right, so let's convert the following measurements into liters. So, oh, whoops. There we go, this page. Let's convert the following measurements into liters. So let's say you're working at a hospital and you have 8 gallons of liquid, but you need to know how many liters that is. Or you have 3 gallons. Let's start with 1A. How many liters do you have if you have 3 gallons? So what I would do is I would set up my conversion factor. That would be the first thing I would do, is I would say, okay, 3 gallons, 3GA, and then I multiply that by 4.5 liters. And this is approximate. That's what these signs mean, is approximation. It's not a specific, it's not a very exact quantity. It's just meant to be an approximation. And then, so 4.5 liters divide by 1 gallon. All right, so 3 times 4.5, and watch how the units cancel. That's the best part of this, is that the units are canceling, right? So gallons is canceling with gallons, and I'm left with liters. So 3 times 4.5 equals 13.5 liters. So I could write that in right here, 13.5 liters. 8 gallons. So I'm going to multiply that by the same conversion factor, which is 4.5 over 1, or I could just do 8 times 4.5 equals 36 liters, right? 16 and a half gallons, so 16.5 gallons times 4.5 liters over 1 gallon. My units are canceling. That's a good sign. Okay, so 16.5 divided by 4.5 equals 74.25. All right. How about pint conversions? How can I convert a pint over into a liters? So fortunately, I have pint conversions right here. So that means that I can actually do the conversion. Once I know, okay, yeah, no worries, Aaron. I'm recording class, so I'll put this up on YouTube for you to see later. Okay. So let's see. Right, so I have 5 pints, but I need to know how many liters I have, right? So that's the goal, is to convert to liters. So all I need to do is set up my conversion factor. So how many liters do I have if I have 5 pints? I'm going to wait for you guys to do the calculation. Please share with me in the chat once you've calculated it. Okay, so Sandy and Alexandra are saying 2.85. Don't forget your units. 2.85 liters. So what I would do is multiply 5 times 0.75, or 57 is 2.85. Yeah, so I thought I'd just double check. And how about this last one? This last one looks a little strange here. It says 4 gallons, 1 pint. So that means 4 gallons plus 1 pint. So what I would do is just convert gallons separately from the pints. So 4 gallons, 4 GAL times 4.5 liters over 1 gallon. This equals 4 times 4.5. This equals 18. And the 1 pint equals 0.57 liters. So if we add that together, we're going to get, so if I summate, that's what, this is a sigma. It's a Greek symbol for summation. I'm just going to add the two together. So that's equal to 18.57 liters. All right, 18.57. Awesome. Yeah.
I have a quick question.
Yeah.
Like, I mean, this is converting metric to imperial measurements, but these are not US gallons or pints because they're like, yeah, like 0.57 liters for 1 pint. That's British. And in the US it would be like 0.47 or something like that. So like, are we just doing this to learn how to convert? Because these are not numbers we're ever going to use in Canada, because we don't get British measurements like if we buy an American product. Do you know what I mean?
Yeah.
If you buy 1 pint or let's say 1 quart of cream in the United States, you would get less than 400 something liters or milliliters.
Yeah.
You know what I mean?
So the point of the exercise is to know how to convert. And I'm happy you picked that up, that this is the British Imperial. Is this British Imperial measurements? Are these British Imperial measurements, like these numbers?
Imperial is British, and then it would be like US, you know, the other ones
Customary.
US.
It says UK right down at the bottom.
Oh, it does?
Yeah. Doingmaths.co.uk. So
Yeah. Okay. Yeah. But I think the point of the exercise is to learn how to do the conversions. Yeah. Like let's say we have American products, then of course you need to know the American conversion. So I'm hoping, okay, so this is doing maths.uk.com as well. So, and then there's also trying to convert from Celsius to Fahrenheit. So yeah, you make a fair point that in order to convert from an American unit, you need to have the American conversions in front of you. That's correct. Yeah. So the point of the exercise, though, is to learn how to do the conversion. Yeah. Okay, and then I'm going to read out Ryan's question. Since both equations are in relative units of measurement, couldn't we just add the 4.5 and the 0.57? 0.57.
1 gallon is equal to 4.5 liters, and 1 pint is equal to 0.57 liters, and they're both in equal units of measurement. So if you just added that and you get 5.07 liters and then multiply it by the original factor, it'd give you the same answer.
Oh, does it?
Yes.
Oh, okay. So
instead of having to do it in 2 separate parts.
Oh, okay. Yeah. I like to break it apart and then do it one step at a time. That's just the way I do things. But anyway, yeah, if that's what works for you, that's what works for you. Yeah, if that's what floats your boat. Let's see. So as a decimal. Yeah. So could you explain that again, maybe a bit slower, just so that people can understand?
Yeah. So since the question's asking us for 4 gallons in 1 pint, we know that 1 gallon is 4.5 liters, and we know that 1 pint is 0.57 liters. And since they're both in liters, you can add the 4.5 basically, and the 0.57. So in this case, you would add the, or wouldn't that? Yeah, no, that'd be 1 gallon, 1 pint. Sorry, I'm looking at it. But if you multiply it, and then you'd have to subtract the 0.57 times 3 after, because it's not the same. number. Yeah, no, I was gonna say you could take that 5.07 and multiply it, but then if you did that, you'd have it would be equal to 4 gallons and 4 pints, and then you'd have to just subtract after. So it's probably easier not to do that.
Right. Okay. Yeah.
Sorry, I made it
like
more
to break it
confusing than it
down.
had to be.
I like to break it down into steps and then just add up everything together at the end. Yeah. Let's see. Okay. So what's going on in the chat? There is a question here. Will the conversion factors be provided on the tests? Yes, I will be giving you, I'm not asking you to memorize conversion factors. I will be providing the conversion factors on the tests. 5.07, what does that mean?
Well, what it means is if we were, I was just like, part of my question was that you wouldn't get the right answer. You get 20 decimal something, and it's 18.57. So I was just saying, like, if you add 1 gallon and 1 pint, but then you would be multiplying a gallon and a pint times what? What was the question again? I think it was 4 gallons and 1 pint. So I was just trying to wrap my head around it to see if I misunderstood. But he clarified that, if you did it that way, you'd still have to subtract the extra pints that you calculated in the 3 pints, right?
Yeah.
Don't worry about it. Sorry. It's just, yeah.
Just break it down into steps. That's what I would think is the best way. Yeah. All right. Let's see here. So how about, so they have DP, and I'm wondering what DP stands for because I don't see any conversion factors for DP. So convert the following measurements into gallons, giving your answers to two decimal places. That's what that stands for. Okay. So now we're converting from liters back up to gallons. So we're doing the exact opposite. So what we do here is we multiply this by 1 gallon, divide by 4.5 liters. So instead of having the 4.5 in the numerator, we now have it in the denominator because we now need the units to cancel out. So we see liters is on the bottom, liters is on the top, and now it's canceling to give us the conversion. So 6 divided by 4.5, out comes the calculator. 6 divided by 4.5 is 1.33. So now we have our answer for that conversion. All right. And then you do the same for the rest, and they'd like the answers to 2 decimal places. That's what that means right there. Yeah, so whatever you're looking for goes on the top in terms of units. That's correct, Kaylin. That's right, yeah. So if you're looking for gallons, gallons goes on the top. If you're looking for pints, pints goes on the top. But you got to make sure that you have your units canceling out in terms of what's on the top and what's on the bottom. Apparently my internet connection's unstable at the moment, so if I cut out, my apologies. My apologies in advance. Okay. Any questions about that one so far? Let's do a couple more examples here. So let's say for 180 liters, we're going to convert that over to gallons. We'll multiply this by 1 gallon over 4.5 liters. So we're going to cancel out our units. Liters cancels with liters, and we're left with gallons. So 180 divided by 4.5, 180 divided by 4.5 equals 40. And then GA, I don't know how they short form or abbreviate gallons, but I'm going to abbreviate it GA. All right. Okay, let's try one more. We're going to multiply this by our conversion factor. So this is the conversion factor right up top at the very top left. So multiply this by 1 gallon divided by 4.5 liters. Liters cancels with liters, and we're left with 0.5 divided by 4.5 equals 0.011111. So we'll just round that to 2 decimal places, GA. So that's the way we would convert from liters back over to gallons. All right. Convert the following measurements into pints, giving your answers to 2 decimal places. So liters to pints. So what is our conversion factor? It's 0.57 liters equals 1 pint. Okay, so what we do here is we set it up. We're going to say 4 liters, we'll multiply this by 1 pint goes on the top. That's what you're looking for, right, Kaylin? I believe Kaylin was asking the question earlier. Yeah, so whatever you're looking for goes on the top. That's correct. 1 pint goes on the top. And then you divide that by what's going on the bottom to cancel out liters. So that's 0.57 liters. So I'm going to zoom right in. Where did it go? Okay. And then, so this is what's going to cancel. Liters cancels with liters. And we're left with the amount of pints that's left over. So 4 divided by 0.57 equals 7.02 pints. All right, so then you do the same thing, except there's a couple curveballs that are thrown in here. There's one right here, so 200 milliliters. What would we do with this 200 milliliters? That's a bit of a curveball. How would we convert 200 milliliters to pints? Go ahead, Ryan, sorry.
Oh, I was going to say it's like a 2-step question where you have to convert it to the unit liters and then convert it to pints afterwards.
Okay, so can you walk me through how I would do that?
So 200 milliliters to liters. So we know that there is 1,000 milliliters in 1 liter. So you're going to take 200 divided by 1 over the unit of measurement, which is 1,000. And
Okay.
you're going to end up with 0.2.
Yep, 0.2. And what's my unit?
Liters, sorry.
Yep, awesome.
And then you're going to use that in the second part of the question.
Okay, times.
So times 1 pint over 0.57 liters.
Okay, and what does that equal? Do you have a calculator?
Yeah, hold on a sec here. It comes out to 0.114, or rounded off to 2 decimal places would be 0.11.
Try that one more
Or
time.
wait, sorry, no, I'm multiplying, my bad, hold on. Sorry.
That's okay.
Give me a sec here.
I thought
Sorry,
maybe
0.35 is the answer.
Okay, 0.35
liters, or sorry, pints.
pints.
I'm
Awesome.
having a day.
That's okay. I'm having a day too. Yeah. All right, awesome. So yeah, it's a 2-step question. So first convert milliliters over to liters, as Ryan said. And then the next step is convert liters over to pints using the conversion factor. Thanks, Ryan. All right, for each pair of measurements, circle the largest volume. So how would we compare 2 different volumes that are in 2 different units? How do we know which one's bigger?
We try and bring it to same values first.
Okay. And how?
Then,
okay.
So like, if it's like 4 gallons or 20 gallons, then I would convert gallons to liters, and accordingly I can say that, okay, this one is larger than liters. And
okay.
Yeah.
Okay, so how would we convert gallons to liters?
So I would be multiplying 1 gallon. So 1 gallon is 4.5 liters. So 4 gallon is 4 into 4.5.
Okay, 4 gallons times 4.5 liters per 1 gallon. Okay, and what does that equal? Do you have your calculator handy?
Yeah, it is going to be 18 liters.
Okay, so 18.
Yeah, 1/8.
So which one's greater, 18 liters or 20 liters?
20 liters is greater than 18.
Awesome, yeah. So then you'd circle the largest volume. Thank you. Yes, that's awesome. All right, and then what about gallons and pints in this question? So thank you, Kanan. All right, so 3B. 6 gallons and 1 pint or 25 liters. How do we know which one is greater than the other one? Or how do we know which one is the largest volume between these two?
You want me to answer that?
Do the same math that you just did.
Yeah, exactly. So 6 gallons times 4.5 liters per 1 gallon, right? What does that equal? So what's 6 times 4.5?
27?
Yeah, 27. So we already know that this one is greater than the other one. We don't even need to do the other conversion because 27 liters is greater than 25 liters. Although we could do the 1 pint conversion just for the sake of it, just for the heck of it, but we don't need to for that case. All right. What else do we have to do here? So let's see. There's a couple more examples. How about the last question here? So a restaurant sells 500 milliliter bottles of Coke for £2 or 1 pint of Coke for $2.25. Which is the best value for money? I'm going to set you guys out in breakout rooms to solve this one. So just write this question down real quick and I'll ask you to solve it in a breakout room. So I'll give you about 5 minutes to solve it. We'll come back at about 1:38 and we'll discuss the answer. Okay, sound good? So I'll give you another 10-20 seconds to write this question down. And you might need a couple conversion factors too. So I'll scroll up so you can see the conversion factors as well. Oops, I think I scrolled too much. Okay. So 1 gallon equals 4.5 liters, 1 pint equals 0.57 liters. And the restaurant sells 500 milliliter bottles of Coke for £2, or 1 pint of Coke for £2.25. Which is the best value for money? All right, I'm going to set you out into breakout rooms. There'll be 3 people per breakout room. That's oftentimes the best number is 3, I find. All right, and then you can discuss amongst yourselves which one is the best deal, and we'll report back at, I'll say 1:38. Okay, sound good? Awesome. All right. Okay. Whoop. So you should receive an invitation.
Sorry, my internet cut out for a second.
That's okay. Which breakout room would you like to go to? I'm just going to send you to breakout room.
I was in 7.
Okay, I'll send you back to 7. There you go.
Okay, perfect. Thank you.
All right, which one is the best value? Option A or option B?
I don't really know. I didn't get much of a chance to kind of really do anything. We were having some technical difficulties.
Pardon me? Can you speak up a little bit?
Sorry. I didn't get it. Give me a second here. I didn't get a chance to do much of anything because I was having some difficulties. First, I was alone, and then she was in my group, and then I was alone again, and then I ended up in a group with Rebecca and I think Melanie. So
Yeah.
I kind of didn't get much of a chance to really do anything.
Oh, okay. So option A or option B, which one did the other breakout rooms determine was the best option or most value for your money?
We couldn't really determine one because there's not much of a difference. Like we converted both of them to liters. But there's not much of a difference. So I think we went with A. I think is the.
Okay.
I don't know.
Oh, I was gonna say, like, what I did was I took the pints, converted over to liters, converted it from 0.57 liters over to milliliters, which is 570. And then I just divided it by the cost for each one. And then it gave me a unit of measurement, which was how many milliliters per $1. And I found out that the two different ones, option A, which is the one that was a 1 pint, was a better value.
Okay, so how many mils per pound?
It gave me 253.33 milliliters per dollar.
250.33 milliliters.
253
Okay, 253.33
milliliters per $1.
Okay, and then I'll do like the British
Euro something.
I think it's the pound, yeah. And then okay, so that's option A, and then the other option was
So then I took 500 milliliters and divided by $2, which gave me 250 milliliters.
250 mil, is it 250 milliliters?
Yeah, well, 500 milliliters divided by $2, which would be, or yeah, divided by $2, which is 250 milliliters.
Okay. 250
And then it's
milliliters, is that right?
per
250
dollar.
mils divide by how many pounds? Divide by
2.
okay, and so what was your ratio of mils per pound?
250 per 1 pound.
Okay, so which one was the better choice?
Option A.
Okay, yeah, because you're getting 3 extra milliliters for 1 pound.
It's really
Yeah.
not that much of a difference.
It's really not that much of a difference. That's right. Yeah. Okay, so option A apparently was a bit better. So the way I would tackle this question if I was doing this is I would have basically done dollars per milliliter, and I would have done or I would have done pounds per milliliter. So it would have basically been like this. Oh, whoops, that's not the way I wanted to write that. I wanted to write it like this. So pounds, $2 pounds per 500 ml. And then over off to this side, I would have done 2.25 and then converted 1 pint into milliliters. And then so 1 pint is equal to 570 mils. So I would have divided that by 570 milliliters. And then this would have given me dollars per mil, right? So 2 over 500. So is there a breakout room that did this a different way?
Yes,
That's
we
the
did.
way I did it. But
Okay.
I think that Ryan is right, and this calculation doesn't provide you with any useful information, because the reality is you end up with 0.004 cents, let's say, but you can't actually pay less than 1 cent. We'll just use that as a unit. And then on the other side, you have 0.39 cents, which would round up to what? 4. So I did it the way you just wrote it down, but I don't think that's the right way to calculate it. Because anyway, whatever.
Okay, and then I think there was a second person that said that they did a different way.
Yeah, I
okay,
converted milliliters into liters.
okay,
Converted into liters where it's like easier to go that way, and then I divided it by €2 and then 2.25 at the end. So it basically gave me same answers. So for the first 500 milliliters, I converted it to like 2 liters, and then divided by 2 euros, which gave me 0.25. And then
Okay.
for 1 pint, I just converted into liters, like 0.57, and then divided by 2.25, which gave me 0.253
Okay, so 0.253 liters per
euros.
euro. So which one is better, option A or option B?
Option A, because like that did not give me any other significant numbers or something. But if I round up the second one, it is almost the same. But again, I would just choose option A because it was
Okay.
0.25. But I don't know whether am I correct if I just convert the milliliters to liters and put it that way in the answer.
Yeah, it's fine. Although these are approximations, so they're not accurate to multiple decimal places. So that's the other thing to pay attention to, is that in order to do like a full cost comparison, you might need a conversion factor that's more accurate than what was provided. So that's another thing to pay attention to as well. All right. Any other strategies that were out there that different groups used? It seems like option A was more the option, or you were given more value by choosing the first option, which was 500 mils of Coke for 2 pounds. All right, so that covers volume conversions. So let's move on to weight conversions. How about we're going to look at converting pounds to kilograms. So there's about 10 different math drills right here, but it's pretty much the same thing. So once you get the first drill, it should be fairly easy to get the second, third, and fourth. Okay, so how many pounds are in 7 kilograms? What would be the first step that I would do in order to convert 7 kilograms over to pounds?
Okay, how many pounds are in 1 kilogram?
Okay, so how many pounds are in 1 kilogram?
2.205.
Okay, 2.205 lb are in 1 kilogram. Okay.
And then I was going to say, take the 2.205 and then multiply it by 7 kilograms over. Then you basically would end up with 14, what was that number? 14.410.
Okay, so 7 times 2.205 equals, I'm getting a different number.
Oh,
Do you
sorry, I
have
just the calculation in my head.
Okay.
Sorry. I don't trust my calculations in my head today. Sorry, I apologize.
Yeah, that's all right.
Yeah, so yeah, 15.435 pounds.
Okay, for 15.435 lb. All right, so once you know how to do it one time, it should be fairly straightforward how to do it the second, third, and fourth times. So how many kilograms are in 2.2 pounds? So we would do the exact same procedure again. So all that we have to do is set up pounds up top. So 22L. Oh, how many kilograms? Okay, never mind. These are what I'm looking at over on the right-hand column is different than what's on the left-hand column. Left-hand column is taking kilograms and converting it over to pounds. Right-hand column is taking it from pounds and converting it over to kilograms. Okay. Sorry, I thought I was seeing the same thing, but it's actually different. It's the opposite. Okay, so 22 pounds, and then I'd be multiplying by my conversion factor. So there's 1 kilogram is equal to 2.205 lb. All right. So 22 divided by 2.205 equals 9.9. I'm just going to keep 2 decimal places, so 9.898 kg. So I want to point out here that there's 2 different ways to solve this. First, you can solve it the way I just did, or there's another way to do it, and that's using the different conversion factor. There's 2 separate conversion factors, right? You can use the first conversion factor, or you can use the second one. So 22 lb times, and then there is 0.454 kilograms per 1 pound. And then that'll get us, that'll also allow us to do the same conversion factor. So it should bring us the same number multiplied by 0.454 kilograms equals 9.98 kg. So I just want to make sure that I highlight and I show you that the units are canceling. The units are canceling here as well, and that's why we're getting the same number. All right, so once I do it once, it should be fairly straightforward in how to do it the rest of the time. So I could set you out into a breakout room in order to complete this sheet together, or I don't know. What would sound good to you? Should we just continue with the material, or should we go into a breakout room and work on finishing this this worksheet? I should take a poll. If I had a poll prepared, that's what I would ask. Breakout room time or continue with the material? So James is saying continue with the material, so let's continue with the material. Stay on the worksheet. Okay. All right. So once I've done it once, it's fairly easy to reproduce the pattern. All that we have to do is make sure that the units that we want are in the numerator. The units that we're dividing out are also canceling out as well, right? Okay. So how many kilograms are in 250 pounds? So let's say you're charting one of your patients. One of your patients is 250 pounds, but you need to know how many kilograms that patient is. You're going to have to convert 250 pounds back into kilograms because that's the way the chart is written. So 250 pounds. Whoop, that's not the color. All right, 250 pounds. And then we're going to multiply by kilograms per pound. So let's say there's 1 kilogram in 2.205 pounds. So this equals, so pounds cancels with pounds, and what we're left with is 250 divided by 2.205 equals, so this is 100, whoops, 113.38 kilograms. All right, so that's our final answer there. What's going on in the chat? Yeah, so a lot of people are saying that they got 113.5. Well, it's 113.38. I can't be I've been lost this one. Okay. All right. Sorry if I'm losing anyone. So Katie, where did I lose you for this conversion?
You actually lost me from the beginning of the class.
What happened?
Everything. I don't understand this class today, so I messaged you and I'm hoping that maybe we can meet one-on-one or something because I can't understand anything.
Does it make sense the conversion of 1 kilogram equals 2.205 pounds? Does this conversion, like the
That
equivalency?
doesn't. I do understand that. I don't understand how you're putting things on paper, and it's going way too fast for me.
Okay. How about if I talk money? How many dimes are in a dollar?
Well, I get that. Like, there's 10 dimes in a dollar, right?
Yeah.
But
how many quarters are in a dollar?
4.
Yeah. So it's basically those are the types of conversions that we're using, except instead of money, we're looking at weights and we're looking at length.
Oh, it's how you put it on paper and you're canceling things out, and the word problems, you lost me, and decameters, centimeters, millimeters, all of it, everything. So I'm not going to keep the class going on my stuff because I really don't have a clue.
So, I'm sorry to hear that.
That's okay.
Yeah. All right. Well, hopefully we can make it make sense at some point in time. All right. Okay. So,
Question for you.
Yeah, go ahead, Tia.
So I did it the other way and put the kilograms, like 0.454 on top.
Yeah. Okay.
For 1 pound, and I got a slightly different answer, but does that matter? Like I got the 113.5.
Oh, okay. And so you got the 0.454. So the reason why they're a bit different is this one is accurate to 4 sig figs, whereas that one is accurate to only 3. So perhaps that might be one of the reasons why there's a bit of a difference.
Okay, like would you mark it wrong then, or would you just try and do both and see what?
No, I would mark it wrong.
Okay.
Yeah, especially if I'm providing the conversion factors, then I would be calculating it both ways myself, and then yeah, I would mark it wrong. But yeah, you got like the main idea, so you'd get like at least like I would have to give you full marks for that. Yeah.
Okay.
Yeah. All right.
Would it maybe help, not to keep everybody behind, but if you wrote your equations like like the way I don't even know how to explain this because everybody's high school experience would be different, but like grade 9 math for me, it was like cross multiplication, right? And that's what we're doing, but you're not actually writing out the answer. So like for example, what's in front of me right now, 250 pounds times 2.205 pounds, right? And that you could write that what is it? It's 113, right? But and then 250 pounds over what you're solving for is nothing. So the way I learned how to do is you nothing times one is nothing. So then your answer is 113.38. Like I think it's just for me, I can't speak for Katie, but maybe she's not used to seeing this equation written like that. So if I saw that for the first time, I'd probably be lost. And then I get like a mental block, and it doesn't matter what else you're saying, I'm still stuck on the first thing. So I don't know if that would help her. And if I'm even right at all. Is that it's cross multiplication, right? That's what we're doing.
Yeah, it is.
Okay.
Yeah. So, I mean, I could actually explain this a couple different ways. So, here, let me zoom back out. Okay, so what's going on here is actually, you could say how many kilograms are in 250 pounds. So it's X kilograms over 250 pounds. And then we set it up, it's cross multiplication with the conversion factor. So the conversion factor has to be kilograms over pounds. So we could pick this conversion factor or we could pick this one. Both are equally valid. So 1 kilogram or 2.205 pounds. And then, so what it is cross multiplication actually, right? So X kilograms is equal to 1 kilogram over 2.205 lbs times, right? So what I'm going to do on the left-hand side, I have to do on my right-hand side in order to cancel this out. So see how it cancels on the right, on the left-hand side. So 250 pounds is canceling with 250 pounds. And then that's what leaves me with 250. So see how now the units are canceling because I have pounds divided by pounds. That cancels out with itself. And what I'm left with is kilograms. So 250 pounds divided by 2.205 gives me 113.38. 113.38 L, is it, it's kilograms, correct? Okay, so that's another way of looking at it, is doing cross multiplication. Is that what you're getting at, Adam?
Yeah, no, that's it. It's just that like the equation you're writing, all of that is included in it. But if you don't know how to do what you just did here, this cross multiplication, that was never taught to you. And I don't know which curriculum Katie, used during high school. Like I know that I'm older than some people, and I had the old style, and it was completely different. And then they changed it like in 1999 or something like that. And I think that that could be where,
See, I don't remember any of this, but the only thing that I'm doing to keep it simple in my very simple mind is that I have to make sure that whatever I have, I know of, like, so the 250 pounds, I got the pounds, whatever is there, whatever unit that is, it has to go on the bottom. And then I just slide it over because it's usually going to be a 1. And then I just either divide it or I'm timesing it. Simple. I keep it super simple. All this cross shit, I can't even look at you do it, Emily, because I know you know it and you go through it so quick. But for me, as long as I know that whatever unit I have, if it's kilograms here, diagonal, it's got to be kilograms here. If it's pounds, it's got to be pounds. And it's always either the one on the top or the bottom. And it's just, that's the simplest way I do. I don't know if that's going to work for you, Katie, but that's,
I feel
what
the same way.
Yeah.
So I'm completely lost, and I'm actually older than you, Adam. So I learned the same way you did, but I still don't. It's you're teaching too fast for me and too many steps that I don't understand. That you go ahead of it and then you go back, and then I don't understand where I'm like, you lost me in between everything. And then, like Adam said, I'm just stuck at that one spot trying to figure it out.
And
Okay.
I got out of high school about a year and a bit ago, and I'm lost too. So.
Aw, jeepers. Oh no. Okay, so it sounds like I have some of the classes is with me, some of the classes I'm losing them. Okay, so I think I need to start over again. Let's start this class over again. It's not possible, but I wish I could. So where should we start? Right at the beginning?
Yes, please.
Okay. Okay. So we have another 15 minutes, and I can start again here. I'm just going to create a little bit more space. So
Or if it's easier for the class, is there any way we can meet sometime during the week with a couple students that are having troubles? We can do like our own little Zoom meeting.
Well, I don't mind.
Because I don't think 15 minutes is going to get me to where I need to be.
Oh, okay. Well, you know, it's a really a tough call for me to make here because it just seems like I'm having some people are with me, some people I've lost, and so it's really tough call to make. Yeah, we can make a sometime. There's still morning. Yeah, there's still some time tomorrow morning as well. That's correct. Yeah, just trying to. Okay. Sorry, I'm just trying to read what's going on in the chat here. Yeah. Okay.
Okay, I was gonna type this, but it's taking too long. Or maybe just reach out to some other of us students that might know it, because we all seem to understand it in a different way. And maybe you understand it one of the ways that one of us understand it, as opposed to if you're not getting it now, maybe she won't be able to explain it in an even better way. Does that make any sense?
Yes, it does. Yeah. Because I find peer-to-peer learning is actually the best way to learn instead of me saying it the same way I've been saying it again. Go and try to ask like Sandy, try to ask Adam, try to ask like Ryan, Sierra, like James, ask the classmates to see like if they can explain it in a way that would make more sense. Like that kind of takes a little bit of the pressure off my back, although I don't want to put it on anyone else's. Let's see. So when I get stuck on something, I usually go watch a YouTube video. And yeah, so I actually love watching YouTube videos as well, Brianna. And it usually helps getting different perspectives and ways of solving the problem. That's actually a really good point, is go watch YouTube. There's a great YouTube channel called Math Antics, and they present math in a comical, fun kind of way. And it actually like really makes me laugh because, you know, the guy, like his name's Rob, he's always telling jokes and stuff like that, but he's also really good at communicating the principles. So Math Antics is where I would go if you do have time and you'd like to do some research on your own. Math Antics is a great place to start. Yeah. And so Sandy's putting her email out there. So flexfitness@eastlink.ca. And then what else is there? Katie, if you rewatch the first lecture for physics, she explains everything for conversions and it makes so much sense. Excellent. Yeah. I just took grade 12 uni math like 3 months ago. If anyone needs extra help, I don't mind. So Sierra's saying that. Yeah, so I posted some stuff on YouTube as well. Although I have a certain way of explaining things that may or may not jive with everybody. Hopefully it does. Hopefully, it's reaching you, but if it's not, I'm not going to take it personally, but yeah. All right. So we do have 10 minutes left in class. How would you like to spend the rest of class, guys? Continue on with converting lengths.
Can we go over the very first stuff we did? I find everything else, like you provide all of us like the information, we just have to like plug the numbers in. But everything at the very beginning seems like to be the backbone of it. And I don't know why that's the more challenging part for myself.
Oh,
like I can do the math. I just don't know what I think. To me, the beginning almost overcomplicated it. So I just kind of want to hear that again.
Okay, is it the micro, nano, milli, that type of conversions, those type of?
Yeah, so when we were moving the decimal to the exponents, I was getting different number of decimal movements initially. So if we can just go over like a few of those questions again, and then.
Yeah, okay. Let me just save this. So I'm gonna save, hold on one second. Okay. I'm actually gonna start with a fresh sheet. I'm just gonna lighten it up here. There we go. Okay, so we can go over this part again, actually. Okay, so are you talking about this where we're moving decimal places to the left and to the right? Yeah. Okay.
Which is like so simple, but I find when we're trying, like if I have to write it or show it on paper, like I can provide the right answer, but I can't write it out.
Okay. Okay. So here we're converting from microliters to milliliters, and that's something you'll see in the healthcare field. So micro is right.
Right. Like I feel like I do that.
It's
every
right
day,
here.
but I don't. Okay.
Oh, whoops. Okay, I don't want to do that. I want to highlight. There we go. Highlight. Okay, so micro is right here. And we're jumping to milli, right? So this is times 10 to the negative 3, from times 10 to the negative 6 to times 10 to the negative 3. So that means we're going to be moving the decimal place. So negative 6 equals, oh yeah, it has to be subtract. Okay, so negative 6 subtract negative 3. So whenever you see two negatives beside each other, that actually means you're going to be adding them. So negative 6 plus 3 equals.
Also, Emily, you're just your screen's not writing for us.
Okay.
Like, we can't see what you're writing. Sorry.
There we go. Can you see what I see? Or can you see my writing now?
Oh, yeah.
Okay. Sorry. Yeah. Okay. So to go from microliters to milliliters, we're going to have to move the decimal place 3 spots. Now, is it to the left or is it to the right if we're going from micro to milli? We're moving this way, correct? Right.
Oh, sorry, we're going up. Yes. Okay.
It's going to the, so the decimal is going to move how many spaces to the?
To the left.
Yeah. Right? And how many spots is it going to move?
Is it 3?
Yeah, it's going to move three spaces to the left. That's right. So 1 microliter, the decimal is right here actually. So it's going to move 1, 2, 3 spaces to the left. Okay. So what we're left with is 1, 2, 2 zeros, So it's 0.001, and then it's going to be milliliter. Is that correct? No, that doesn't sound right. That doesn't sound right. Let me think about this. Sorry. Convert 1 microliter to milliliters. So we're going from micro to milli. Yeah. Yeah, no, that's correct. Sorry. I'm having one of those days too, but that is correct because we're going from micro to milli. I was just making sure that we were moving the decimal in the correct direction, and to the left is the correct direction. Okay.
Yeah.
Okay, so that's for question number 1. So for question number 2, we're converting from nanograms to milligrams. So nanogram is way down here. So here's nano. And we're converting from nanograms all the way up to milligrams. So nano is times 10 to the negative 9. So it's negative 9 minus negative 3. So negative 9 minus negative 3 equals, how many spaces are we going to move the decimal place? Negative 9 minus negative 3.
Okay.
Yeah.
Or, well,
So,
sorry. Yeah.
So 6 places in total. And if we're going from nano to milli, are we moving the decimal place to the left or to the right?
Oh, to the left?
Yeah, to the left again, right? So 1 nanogram to milligram. We're going to move the decimal place 6 places to the left. So 1, 2, 3, 4, 5, 6. So there's going to be 1, 2, 3, 4, 5. So 0.501. That's how many milligrams there's going to be. 0.000. Sorry, I have to count the number of zeros. Yeah. So 2, 3, 4, 5, 6. So that means 5 zeros. So 1, 2, 3, 4, 5. It should be 6 spaces. So 1, 2, 3, 5, 6. Yeah. Milligrams. So that's converting from 1 nanogram to milligrams. So 1 nanogram is equal to 0.00000. There's 5 zeros right here.
Okay. Yeah. This makes more sense now. This was the only part that went over my head for a second.
Okay. Okay, no problem. All right, so what else is going on in the chat here? Are there any questions for me in the chat?
Looks like there's one. The unit is always 1 in the test. That's what
The unit is always 1 in the test, right? I'm not too sure what that question is saying. What are you saying, Thu? What is that question there? Thu Ha Tran, what is your question? The unit is always 1 in the test, right? I'm not too sure what that question's all about. Sorry. I'm gonna have to put my hands up and say, don't know. The number is always
What
1.
he's asking is that it's always like it says convert 1 microliter to 1 milliliter. Is that always gonna is the number always gonna be 1?
Oh no, there's gonna be non 1 digits as well, like 2 all the way up to 9 as well. Yeah. Just like this one, like 300. Yeah, things like that. Anyway, looks like we're getting close to running out of time, but what we did cover today was conversions of units within the metric system. So we did talk about conversions within masses, within volumes. We also talked about conversions within, what else? It seemed like a lot, but that's where we'll pick up tomorrow, and hopefully we'll have more of your questions can be answered. So, okay, so there's a question here on how to get the French E on the keyboard. Yeah, That happens a lot. That happened to me a lot. You have to Google how to get that off of your keyboard. That used to happen to me. Yeah, Google. Google's your best friend there. There you go. All right. Thanks for your attention, and we'll see you tomorrow morning at 8:30. I'm going to have more practice ready for us for the conversion of units, and hopefully, actually, you know what I'm going to do is I'm going to put in one link into the chat that should help us out. So conversion of units, math antics, something that I'd like you to watch. If you are struggling, this is something that I'd like you to watch. It'll make it a lot easier for you. So there we go. So that's a math antics video. They talk about conversion of distance units, and it actually would clarify a lot of the concepts. If you are lost in this class right now, it would be something that would definitely help you out. But in that case, we'll see you tomorrow morning. I'm going to get ready for tomorrow morning, like right now, and we'll see you tomorrow morning. Okay? Take care, everybody. Thank
Have a
you.
good night.
Thank you.
You too. Take care. Have a good night. Bye-bye.